Hi, in this edition we're going to talk about vertical asymptotes and how to check whether a vertical line is a vertical asymptote to a given function. So let's get started. So first we have to talk about what is a vertical asymptote when defined properly using limits. Well, a line x equals a is said to be a vertical asymptote to the function f of x if and only if at least one of the following is true. And we have six conditions. One, the limit of the function f as x approaches a from the left is positive infinity. Or the limit of the function f as x approaches a from the right is infinity. Or the limit of the function f as x approaches a is infinity. Or the limit of the function f as x approaches a from the left is negative infinity. Or the limit of the function f as x approaches a from the right is negative infinity. Or finally, the limit of the function f as x approaches a is negative infinity. In other words, a vertical line is a vertical asymptote if on one side of it the function approaches infinity or negative infinity, if at least one side of it. All right, so let's make use of this definition to figure out whether given vertical lines are vertical asymptotes to some function. Let's have the first problem. We have here, is x equal to negative 3 a vertical asymptote to the graph of y is equal to 5 plus 4x over x plus 3? So we just have to evaluate whether on one side of x equals negative 3, we can have an infinite limit. So how do we do that? Very easy. So we have evaluate the limit of 5 plus 4x all over x plus 3 as x approaches negative 3 from the left. Okay. The choice of whether the left-hand limit or the right-hand limit, or we need to check both, it depends on you. So at this time, I just want to check the left-hand limit. So let's check. Sir, uh, what will happen here is that I will have 5 plus 4 times negative 3 divided by negative 3 from the left plus 3 is equal to, sir, that's 5 plus negative 12, that's negative 7, divided by negative 3 from the left plus 3 gives us 0 from the left. Or, okay, so negative 3 from the left, you can think about negative 3.1, negative 3.01. So if you add 3 to it, you get a 0, but with a negative polarity. So you get positive infinity. Because we have already satisfied one out of the six conditions, immediately we can already say ah, x equals 3 is VA to the graph, to y is equal to 5 plus 4x divided by x plus. All right, so there you go. Remember, sir, would it have been okay if I check the right hand limit? Yes. Okay. Just to show you, if we check the right hand limit instead of the left hand limit, are you going to arrive at the same conclusion? Okay. So, sir, instead of the left, I take the right hand limit. So the limit of 5 plus 4x divided by x plus 3. Okay, as x approaches, this time, negative 3 from the right. So, sir, I'm going to get 5 plus 4 times negative 3, right? So that should give me Negative 3 from the right plus 3. That's negative 7 divided by 0, but this time plus. Right? Well, you can think of negative 2.9, negative 2.99, okay? And you will get negative infinity. You will see that we still satisfy one of those 6 conditions that we were talking about earlier. Okay, we are still going to satisfy one of these 6 with this result, and still, therefore, we are going to reach at the same conclusion that indeed x equals negative 3 is a vertical asymptote to the given function. Let's have another example. Okay, so are x equals negative 1, 0, or 1 vertical asymptotes to the graph of 1 plus y equals 1 plus x to the fourth over x squared minus x to the fourth. So there are 3 numbers that we have to check here. We were asked, okay, for these 3. X equals negative 1, x equals 0, and x equals 1. Okay, um, let's exercise first negative 1. You have here, what is the limit of 1 plus x to the fourth divided by x squared minus x to the fourth as x approaches negative 1. Say from the left. Again, this is all up to you. So whether you check the left or the right hand limit, it's all right. Okay, it's up to you. If we did that, directly, we're going to have trouble because that's going to give us 1 plus negative 1 raised to the fourth all over negative 1 squared minus negative 1 to the fourth. And we can't really figure out whether this is 0 plus or 0 minus. So that means we still have to do some manipulation first. Okay, we cannot do it directly, so we do instead this. So 1 plus x to the fourth is equal to the limit of 1 plus x to the fourth divided by x squared 1 minus x squared. As x approaches negative 1 from the left. Okay, so this gives us 1 plus negative 1 to the fourth divided by negative 1 squared times 1 minus negative 1 to the left. Okay, so negative 1 to the left squared. Okay, why is that important? Well, because from here, we can do at least some portion, some analysis. So that's 1 plus 1. You have 1 plus 1 divided by 1. Now, you have negative 1 from the left. So these are negative 1.1, negative 1.01. When you square that, you will get a 1 that is greater than 1. You'll get 1.01 or 1.001. So that means that this will be 1 minus 1 plus. Okay, so this is 2 all over 1 minus 1 plus. Sir, this is 2 all over 0 minus. So that means, sir, this is negative infinity. Because I reached this, it's already safe for me to conclude, sir, x equals negative 1 is vertical asymptote to y equals 1 plus x to the fourth all over x squared minus x to the fourth. All right. Now, We move on. X equals 0. Ganun pa rin. What's the limit of 1 plus x to the fourth all over x squared minus x to the fourth as x approaches? This time, I want to check 0 from the right. Okay. Again, the choice is very arbitrary. Okay, I just out of whim, well, not really out of whim, but I just want to check the right hand limit of this. So, sir, this is 1 plus 0 to the fourth all over 0 squared minus 0 to the fourth. Unfortunately, we can't we can't make anything out of the denominator. That means we still have to make an adjustment. Okay. So baka gawin natin yung kanina still, which is, sir, this is the limit of 1 plus x to the fourth divided by x squared 1 minus x squared as x approaches 0 from the right. So this is now 1 plus 0 to the fourth divided by 0 plus squared 1 minus 0 squared. Oh, sir, this is 1 divided by, okay, a number that's close to 0 but positive squared gives you a number that's close to 0 but also positive still. So this is 0 plus times 1, or therefore 1 over 0 plus positive infinity. Oh, so we still can conclude that x is equal to 0 is vertical asymptote also. Okay, so we have already two vertical asymptotes. We're going to check the last one. So 1, how about sir 1? So let's check 1. What's the limit of 1 plus x to the fourth all over x squared minus x to the fourth as x approaches 1 from the left? So again, the choice is arbitrary. I just want to check x is 1 to the left. Okay. This, I think, by the first two, from the first two, the suspicion is justified if we say that we just skip this and simplify first. 1 plus x to the fourth all over x squared 1 minus x squared as x approaches 1 from the left. This will give me 1 plus 1 to the fourth divided by 1 squared times 1 minus 1 from the left and square that. So this is 2 all over 1. Okay, now what is 1 from the left squared? So 1 from the left, think of 0.99. When you square that, it is still 1 but less than 1. So 1 minus something close to 1 but is less than it will give you positive. Diba? So positive 0. So therefore, this is going to result into 2 divided by 0 plus, that's infinity. So we can confirm finally that x equals 1 is also vertical asymptote to y equals 1 plus x to the fourth divided by x squared minus x to the fourth. Okay, so that means that, okay, x equals negative 1 is a vertical asymptote, x equals 0 is also a vertical asymptote, and x equals 1 is also a vertical asymptote. All right, let's move to the last number. Are x equals 1 and 5 vertical asymptotes to the graph x cubed minus x divided by x squared minus 6x plus 5? Okay, so we are asked for the following: x equals 5, x equals 1. Okay? So to check, isa-isahin natin. Let's have, we have what is the limit of x cubed minus x all over x squared minus 6x plus 5 as x approaches 5. Again, the choice is very arbitrary. Let me say 5 from the left. Okay, so I just want it 5 from the left. Of course, you can on your own do 5 from the right. So, the suspicion here is that we need to do simplification first. So let's do the simplification. So this is x times x squared minus 1 all over x minus 5, x minus 1. As x approaches 5 from the left. Further simplification gives me the limit of x minus 1, x plus 1 divided by x minus 5, x minus 1 as x approaches 5 from the left. Okay, luckily we can take out x minus 1. So we have the limit of x plus 1 all over x minus 5 as x approaches 5 from the left. Okay, we can begin our analysis now. This is 5 times 5 plus 1, that's 6, divided by 5 minus 5. Sir, that's 30. Okay, what's 5 minus minus 5? So think of 4.9. If I subtract 5 from 4.9, I will get something close to 0, but is negative. So this is, sir, negative infinity. But the fact is, it's negative infinity. We have already satisfied one of the 6 conditions. One of this is true, no? As we approach 5 from the left, we get negative infinity. That's condition number 4. So that means that we can already conclude that x equals 5 is a vertical asymptote to the function y equals x cubed minus x all over x squared minus 6x plus 5. No? Okay. So, next we check 1. Paano si 1? All right. So, let's check. What's the limit of um, of the function x cubed minus x? Okay, the limit of the function x cubed minus x all over x squared minus 6x plus 5 as x approaches 1. Okay, from the left. Let's see. This is just the limit of, okay, let's do the simplification again. Okay, this is actually x minus 1 divided by, you have x minus 1, x minus 5. Sorry, x minus 1, x plus 1. It's just the same thing as we have done in the previous example. Okay, so this, by the way, as x approaches 1 from the left. So we will have the limit of x plus 1 all over x minus 5 as x approaches 1 from the left, which is equal to 1 times 1 plus 1 all over 1 minus 5. which is equal to 2 over negative 4 or negative 1 half. It's not infinity. It's not an infinite limit. Okay. In fact, there is a number negative 1 half to which the function approaches. Sir, but you only check one from the left. How about one from the right? Well, unfortunately, even if you repeat this process and change this to one from the right, you will get the same limit, which is negative 1 half. Because um, once you do the substitution, you will still arrive at 1 times 1 plus 1 divided by 1 minus 5, which is negative 2 quarters or negative 1 half. So the only conclusion left is to say, sir, x equals 1 is not vertical asymptote to y equals x cubed minus x all over x squared minus 6x plus 5. And there you have it. So in this case, to conclude, x equals 5 is vertical asymptote, but x equals 1 and it's not vertical asymptote. All right, so there you have it. See you next time.